Okay, let me take this opportunity again once more to be able to talk about paper 3. First, let me apologize for the first recording, which was not clear of the video. Now, the video is about paper 3, chemistry practical 233 stroke 3. And the two key areas I wanted to discuss and give knowledge about it is quantitative analysis and the qualitative analysis. A practical paper is a compulsory paper and it is the backbone of the two theory papers. For a student, you have to do well, you have to perform well in that area so that you can get a quality grade. Now, in these two areas, which are covered by paper 3, the quantitative analysis and qualitative analysis, we shall have a brief discussion on the two. I started the first one, that is quantitative analysis. The first question is supposed to ask yourself, what is involved in quantitative analysis? And which areas are being covered by quantitative analysis? Now, the areas covered by quantitative analysis are titration, energy changes, and the rates of reaction. So in the exam, you can either get a titration question with energy changes plus a qualitative, or energy changes, qualitative, and titration. Now, on these areas, we like to look on the first one, that is titration volumetric analysis. What is required and what is expected in titration? It involves using a burette, a pipette, reagents, and indicators. The question set on the titration one is completing of the table. The table has a maximum of 4 marks, and the 3 marks, you can obtain them free without struggling. And one of the first mark is completing the table by giving the realistic values. When you fill the table with the realistic values, then you're in a better position to score the 1 mark. Then the second free mark is all the values must possess a decimal point. So all the values must possess a decimal point, and these values must be realistic, above 5 and less than 50. Because the burette reads from 0 to 50. You cannot have a value of 60 until it's a realistic value. So when you indicate the value of 60, it means this is a student who doesn't know what he's doing, cannot be able to read a burette. And the reagents and indicators, then third mark, it is 2 values or 3 values must be equal or have a difference of plus of 0.1. If the values have a plus or minus 0.2, you score half a mark, so to a maximum of 2.5. Then the last point is the accuracy, that's the fourth mark. This is plus or minus 0.1, the value of the school value. School value is whereby the teacher sits down and do the practical, and that will become your school value. If the teacher forgets to do the practical, then all the average volumes of all the candidates are added and averaged, and the value obtained becomes the school value. Now, the next question is find the average. We call it the principle of averaging. Which values can you pick from your table? Now, the values which can give you a full mark, it is if all the values are equal or they have a difference of plus or minus 0.1, you score a full mark. And in case if the values you have picked have a difference of plus or minus 0.2, you score half a mark. And if the difference is greater than plus or minus 0.2, you score 0. So please take note on that area when you've been asked to calculate the average volume. Then look at the values which have a difference of plus or minus 0.1 or are equal so that you can score that 1 mark. Now, the next area I've covered is the calculation. And the first part we expect most of the time is finding the number of moles of a solute. And if you've been asked to find the number of moles of a solute, you have to recall the formula that to get the number of moles, it is molarity marked by volume divided by 1,000. The answer must be in 4 decimal places unless to divide it exactly. And the units is M or L, small m, small o, and small l. Then the other area can be asked under calculation is the concentration in moles per liter. This term really confuses our students. Once they've been asked concentration in moles per liter, they do a lot of calculation and they divide again by 1,000, and that is a wrong approach. In case you've been asked for concentration in moles per liter, this means molarity. Now, bring in the formula of finding the molarity. There are 2 ways of getting the molarity. One, It is the number of moles multiplied by 1,000 divided by volume in liters, in cubic centimeters, or you can get the molarity by concentration in grams per liter divided by relative formula mass of the solute. Now, in case you've been asked to find the relative formula mass during the calculation, then you should know that the relative formula mass is obtained by concentration in grams per liter divided by molarity. And in case you've been asked to find the concentration in grams per liter, then that is relative formula mass multiplied by molarity of the solute. Now, another part of quantitative analysis, it is energy changes. Now, energy changes involves the thermometer. Energy changes involve plotting of a graph. Energy changes involve completing of the table. Now, during the completing of the table, there's one point which is very, very important. It's your values. There's something called trend. The values must show a trend. Either they are increasing or they are decreasing, or the increase, then have a constant value showing that a reaction has taken place and the reaction has come to an end. Then accuracy still depends on the teacher. And when you're putting down the records of the thermometer, it's not a mass, you indicate a decimal point. The values are accepted as a decimal point. Now, something else you can expect from the question of energy changes is plotting a graph from your values. Now, the type of a graph expected, one is exothermic or endothermic graph. Another is a displacement graph, either exothermic or endothermic. Then a heat of solution graph. It can also be exothermic or endothermic. Then a heat of neutralization graph that can also be, most of the time, all the neutralization are exothermic. Heat is being given out to the surrounding. Now, calculations. The calculations, the first question you can expect is the heat of reaction. And there's only simple formula, capital M, C, delta T. M stands for the mass, which is the volume of the solution. C stands for specific heat capacity, which is 4.2 joules per gram per Kelvin. It is always provided on the stem of the question. And delta T is obtained by getting your the difference between your highest temperature and the lowest temperature, or final temperature and initial temperature. Now, enthalpy of reaction, when you ask the enthalpy of reaction, means this is the molar heat of reaction, and it has the following steps. Step number one, you have to find the number of moles of the solute or solution. Then number two, relate the information. This is where you have the X moles and the number of moles and the joules being liberated, the energy being liberated. So you take 1 mole multiplied by the energy liberated, divide by moles and divide by 1,000. And the final answer must be in kilojoules per hour per mole. Now, take note that if the temperature of the thermometer increases, then the final delta H is supposed to be negative, indicating the reaction is exothermic. And if the temperature decreases during the reaction, it means the final delta H is positive, and that's an endothermic reaction. Now, area number 3. It is involved rates of reaction. In rates of reaction, we have the table. Now, in the table, we're supposed to put in the values, and the values is the reading, and all the reading must have decimal places. And all the readings must be in seconds. The rate value, before we go to the rate, I'm saying the seconds. For example, you have 1.2.06, then it means that is 62. That is 1 minute. They go to 60 seconds, and 2, it means 2 seconds. So you add, we say that is 62 seconds, 0.06, that is a microseconds, are given in decimal place. Now, the next row you'll be asked is the rate, which is 1/T. You should not put fraction values. What is expected? You divide and get the decimal fraction, and the decimal fraction must be to 4 decimal places unless it divides exactly. And once you've been asked to plot the graph, you use 2 decimal places. Now, the 4 decimal places will be converted to 2 decimal places for the drawing of the graph. Now, the expected graphs, one can be a straight line, another one can be a curve, depending on the question how it has been stated. Now, reading from the graph is that the only calculation. It is the only calculation you can be asked. And reading from the graph, you have to go to the graph and find the value. For example, what I have here, I have the rate and I have the volume. Then now you've been asked to find the time at a certain volume. So when you get 1 over t, then you get t, you take that one, divide by the value of the rate, and therefore you get the time. Now that's the small direction. That's how it's supposed to work. There are no any other calculation when you get a question on the rate of reaction. Now, second area, it is the qualitative analysis. Qualitative analysis, this is a compulsory area. As a student, you must expect, you must have the knowledge. And this was taught in Form 3, the last topic in Form 3. So you have to master it. If you're going to cram, you're going to do any other means so that you can be able to understand and master the concept so that you can be able to use it during your practical. Now, in qualitative analysis, the word qualitative means quality, and the quality means identification of the ions in a given salt. Most of our salts are white, so it's not easy to identify the cation and anion present in the given salt. Now, for you to get good results, you must accurately identify the reagents to use. We also be in a position to identify what the reagents test and predict the expected results. Now, these 3 areas, when you master them, they can also guide you to get the correct answer. Now, what are the expectations in the exam? Under qualitative analysis, 1, it is a question in anorganic or a question on organic, or both questions appear in the same paper. One in organic or another one is organic being tested at the same time. Now, for a student, you're supposed to have the knowledge of the reagents which are being used. What do they test? Are they testing cations? Are they testing anions? What type of observation are you expecting? And what type of a reference can you give? Now, the solution for testing cations. Cations, these are metal ions. It's supposed to recharge ions. We are using 2 molar sodium hydroxide, that is NOH. We can use 2 molar ammonia solution, that is NH3. We can use dilute sulfuric 6 acid H2SO4, sodium sulfate Na2SO4, potassium sulfate K2SO4. We can also be able to use nichrome wire or spatula by dipping in the solution and bring it into the flame test to bring to the non-luminous flame. This is called a flame test. And most of the cations give a different type of color of the flame. Then we have hydrochloric acid, we have sodium chloride, we have potassium chloride, and we have potassium iodide. Now, these are the key reagents which can be able to identify the type of cations. So what we're supposed to know, if you add sodium hydroxide, what color are you expecting? We have cations giving white precipitate, we have cations giving a blue precipitate, we have cations giving a green precipitate. And once you get the white precipitate, green precipitate, and blue precipitate, you should be in a position also to tell which type of the ions are present when you're giving your inferences. Now, when it comes to the solutions testing for anions, the reagent used to test for anions, one is barium nitrate or barium chloride. And added to any solution, we are expecting a white precipitate, or we are not expecting a white precipitate. Now, when we expect we get a white precipitate, you have to ask yourself what type of the anions, when reacted with the barium chloride, give insoluble salts of barium, which are white. Then acidified barium nitrate and acidified barium chloride, these solutions also used to identify and separate the sulfate ions and the carbonate and the sulfate ion, whereby if you observe a white precipitate, that gives you a confirmatory test of sulfate ion, and when you get a clear solution or no white precipitate formed, then that one gives you a presence of the carbonate or the sulfite. Then the lead nitrate is also supposed to be used for the anions, and once it is white, we confirm this is chloride, and the sulfate, if it is yellow, iodide ions are present. Acidified potassium dichromate solution, it is always orange, it can turn to green and give the test of the anions present. For more addition of this knowledge, please go back to your notes, Form 3 notes, or go back to a textbook, be book 3 back with. Try to memorize whatever has been written. Otherwise, let us take our work serious. It is the beginning. I've also touched the practical question. So that's the mark which I'll be able to mark on Tuesday and post the results. Otherwise, be blessed.